All right, so as you guys probably saw, we're working this way in Zoom. Feel free to raise your hand and ask questions. Even if we're talking and presenting something, we want you guys to be able to ask questions. To quickly introduce the three of us, I'm Shivani. I'm the engineering manager and sim specialist out of Texas. I've been working with SOLIDWORKS and GoEngineer about 7 to 8 years. GoEngineer, I'm sure you know, we're here to help you make your business really what you want it to be. We're here to support you in any way that we can. With that, let me let Arun introduce himself. He's the best expert we have on simulation here at GoEngineer. Yeah, he's our simulation manager. Arun, if you'd like to introduce yourself.
Thank you so much, Shivani. And Shivani says I'm the best expert. I call her the best expert. I guess both of us are experts in our own right. Like Shivani said, I'm a product manager here at GoEngineer. I've been here for the last six and a half years, supporting the various simulation tools in our SolidWorks desktop portfolio. And I've worked with Shivani and Omar on the line, making a case for customers to adopt simulation in their product development workflow and also getting them up to speed on being very successful with it in their projects. And primarily in field spanning structural analysis, fluid dynamics, and injection molding analysis.
Cool. And Omar, as Arun just said, we call this guy when we don't know what to do. So that just should show what the broad range of knowledge that Omar has. And he's our best resource at Dassault, really. Omar, if you'd like to introduce yourself.
You guys are way too kind. Yeah, so I've been at Dassault for about 11 or 12 years. It's the last couple of years I've been focusing on the SIMULIAworks tools, or the tools from Simulia that are now part of the product offering that we have at SolidWorks. Prior to that, I was at ANSYS, and I worked at Northrop Grumman for a while. So I've been in the simulation space for a while. I'm really happy to be able to be part of this. And like Shivani said, we would really like this to be an interactive session. So if you guys have questions, feel free to ask.
Excellent. All right, so the agenda for today, I'm going to start us off with what SIMULIAworks is and the title of this webinar or roundtable event. The goal of my little section is to tell you how it aligns with products that you may already have experience with, like SolidWorks, and then broadly cover what the core functionalities of it are. Arun's going to jump in and show a demonstration of it, generally highlighting a common workflow that a SolidWorks user may be going through, working with a SolidWorks CAD model, pushing it to the SIMULIAworks program. And then Omar is going to close it off with some really key industry examples done inside of this SIMULIAworks or ABAQUS tool. But again, I want to emphasize, this is about interaction. We want to hear your voice. We want to hear your challenges. Please feel free to jump in at any point that we're talking and ask your questions. And those three things that we're presenting is not going to cover the whole hour and a half of this time that we've set aside. So there's definitely a lot of time at the end where we really want to hear what you guys have to say. So with that, I think I'll go ahead and get started. This should look familiar to hopefully many of you. These are the existing simulation products that have been available to us in the industry for many, many years. On the left-hand side, SolidWorks, our SolidWorks simulation, our SolidWorks flow simulation, and plastics injection molding. That's our FEA, CFD, and injection molding programs. And Simulia, of course, has its own versions of those. You may have heard of ABAQUS. Simulia has many other applications that aren't here on this screen, but I simplified it down just a little bit. The point is, hopefully some of these look familiar. Arun, if you could post up that first poll question, I was curious on whether you guys are using any of these simulation tools when you're doing your own testing, or if you have some other methods that you're using when you run when you test your own products. Excellent.
Very cool.
It'd be interesting to hear what other would be for some of you, maybe later, and what products you're currently doing the various testing in. This is really useful information. Thank you for participating. Do you mind posting up the second poll as well? With 71% of you guys doing finite element analysis, I'm curious on if you're using any of the products I have on my screen. So any of our SOLIDWORKS simulation products would be our FEA, our CFD, plastic injection molding. Maybe you're doing motion analysis in SOLIDWORKS. All of that will kind of apply there. And then on the Simulia side, we have ABAQUS, which is our finite element analysis tool. Or maybe something else in Simulia. That's kind of what that category means.
And there's usually some confusion between what Simulia and ABAQUS is, right? Omar, can you clarify that for our audience?
Yeah, so Simulia is the overarching brand. So like Simulia is the brand that's responsible for developing all of the simulation tools that Dassault Systems owns. So even SOLIDWORKS Simulation, the desktop product, the plastic injection molding product from SOLIDWORKS, all those fall under the Simulia brand. And then ABAQUS, I would argue, is probably the flagship product in the Simulia brand. I'm assuming everybody knows what ABAQUS is. ABAQUS is predominantly a finite element analysis solver, arguably the best one in the market. Really good with like large deformation, complicated contact, really complex material models, very good at cloud computing. So that's kind of the differentiation. ABAQUS is a product, and then Simulia is the overarching brand.
So while you were talking, we had a question come in. Is ABAQUS the solver engine behind the SOLIDWORKS FEA simulation tool? It's a good question.
So ABAQUS, I can take.
Yeah, go ahead.
Yeah, sorry. So ABAQUS is not the solver in the SOLIDWORKS desktop program. It is being developed now by ABAQUS Solver. So many years ago, I think this is the order that it happened. SOLIDWORKS acquired Cosmos, which was an old finite element analysis solver out of USC here in Southern California. And then after that acquisition, I believe Dassault then acquired SOLIDWORKS. And I'm not sure, maybe Dassault acquired SOLIDWORKS first and then they acquired Cosmos, but that's basically the solver that's inside of SOLIDWORKS Desktop. That being said, some of the new capabilities that you're seeing, like the way we handle contacts inside of SOLIDWORKS, the topology optimization, those are products developed by Simulia and the ABAQUS team. So, actually, the topology stuff is by the Tosca team. So you're getting a good merging of the two solvers right now, but the underlying solver inside of SOLIDWORKS Desktop is still the old Cosmos solver.
Thank you. That's perfect. I do. We have a lot of SOLIDWORKS simulation users, which makes sense. These are our GoEngineer family.
So I'm still seeing your screen, Shivani. I'm not sure if I'm supposed to be seeing something else, but
no,
I'm not
that's
seeing
it.
Okay, perfect. Yeah, I'm not seeing the polls.
Good stuff. So we got 87% of people using SOLIDWORKS simulation. Pretty wide range. That's a good number for sure. We didn't see any on the Simulia side, which is interesting. Some ABAQUS, some doing other simulation products. That's some good numbers. Knowing that, what this presentation is really about is the bridge between our SOLIDWORKS simulation tool and the Simulia tool. This is called SIMULIAworks. Again, a brand name covering the bridge between these two products. It is hosted on the 3D Experience platform, and it takes the ease of use, the intuitiveness of many of our SOLIDWORKS products, what really makes it so popular, but then it combines that with the physics and the really industry standard computational power of many of the Simulia applications. On top of this, it's still part of the SOLIDWORKS workflow, where if the big thing about SOLIDWORKS simulation, what makes it so awesome, you make a little design change in SOLIDWORKS, it immediately is there in simulation, and you rerun your test and you have your answer. It's great for iterative testing, fantastic for those during the design process to be able to run these finite element analyses. So that is still possible with SIMULIAworks. We were able to push our design changes and our CAD data from SOLIDWORKS into the tool, making it very iterative. I see something else come in. I saw a question come in. Will Simulia have the discrete solver aspect of ABAQUS? Yes, absolutely. ABAQUS is part of the Simulia brand, so yes, it does have that discrete solver as part of it, and SIMULIAworks does as well. It is using the exact same solver. It is the ABAQUS solver.
And yeah, the same person pointed out, I use that, the product that was acquired was actually Structural Research Analysis Corporation, SRAC. I use that interchangeably with Cosmos, but yeah, I think you're right, Fong, that was Dassault acquired SolidWorks first, and then SRAC, but they happen really close to one another.
Oh, cool. Perfect. I missed that one. All right, good stuff. So seeing this, it's on the 3D Experience platform. It's hosted there. It's actually a range of applications, which you can see here. They have various names, but we have ones for finite element analysis, for CFD, for plastics. But the majority of this presentation, we're really just focusing in on the ABAQUS applications. They're called Structural Performance Engineer or Structural Mechanical Engineer, or SPE or SME. Again, it's just the ABAQUS tool that we're focusing on, the majority of this. All right, we're going to get into some simulation highlights. Arun, haven't you used ABAQUS before?
Yeah, I have used the ABAQUS desktop a long time back, and I have to say, having access to this software, to SIMULIAworks the last 2 years, it's really shown how the interface has evolved. Like you said, it brings in the ease of use that SolidWorks users are accustomed to, and with the functionality and with the power of the ABAQUS solver. What I really like is this is truly evolving into a multi-physics interface. So as we're bringing in more and more physics into the software, it's just a single interface that you interact with to essentially set up different types of problems, whether it's fluid dynamics or structural analysis. The meshing interface is the same. Based on the physics you're trying to solve, you just switch around boundary conditions. That makes it a really good platform for users to test their designs and get a comprehensive idea about their products. And that's one of my favorite aspects of how the ABAQUS solver has essentially been deployed onto the 3D Experience platform.
I like what you're saying. I feel the same way. Like in SolidWorks, when we're just switching between tabs and using different features, it feels a lot like that, switching between these analysis methods in SIMULIAworks.
Right.
It just feels like switching between tabs, and everything else is the same.
Yep. And if you guys are wondering what tabs
impressive.
are, we'll be showing that later in the...
Yeah, we're going to show you guys some tabs.
Yeah.
Okay, I've got about 5 to 7 main technology highlights. I'm not showing the software right, so this will be very broad. I'm going to overview there. Trying to get some screens moved around. Okay, our first main one is general contact. You guys have been using SolidWorks simulation, so you are aware of, that was great, what one of these, if I had to apply something like this inside of SolidWorks Sim, I would be selecting each one of these circular holes and applying a no penetration contact, right? It can be very time consuming. With this general contact method here in SIMULIAworks, it's really just one click. It's one tool that we apply contact for entire part files or entire assemblies. Like I said, really just one or two clicks. So the time savings are, of course, fantastic. But more importantly, we're using ABAQUS's general contact, which is making those component interactions incredibly realistic. Where this part deformed and buckled was very unpredictable, and to be able to accurately represent how this part would react in torsion was fantastic. So that is our first main technology highlight. It's this general contact ability for parts or assemblies.
And Shivani, to draw parallels with SolidWorks simulation, that'll be almost like a global no penetration, right? But way more intelligent.
Way more intelligent.
Yeah.
Because global no penetration, as 71% of you have determined, or say 87% have dealt with, it only works for initially touching faces, or any of these faces that are currently colliding initially touching. No, right? We would have had to do these individually in contact sets. Very cool point. All right, that's our general contact. Let's take a look at our next one. It is about complex materials. This example is going to be on a structure colliding with a rock wall. This is like a bump in that rock wall. And watch as I click through these moments in time, you're seeing more and more elements disappear or get deleted. This is called element deletion. With enough strain, stress, or deformation, it's up to us, these elements will get deleted, and it's a fantastic way to represent something like this where a rock is shattering, to predict how this material is going to react. Now that's just one complex material, right? And honestly, we aren't able to predict how a rock wall shatters unless we have a material that can handle that. So I'm going to go ahead and show you the larger database that we have available here inside of ABAQUS or inside of SIMULIAworks. Let's try to remember, what is the limitation, or how far can SOLIDWORKS simulation go with materials? Off the top of my head, that's about 3 hyperelastic materials, right? Or theories that we can apply. We have elastic plastic materials. We have 1 viscoelastic type. Here I've selected a hyperelastic material, and just take a look at how many theories are available to us here. The more theories that we have, the more accurately we can represent many, many different kinds of materials. And as we know, you don't get an accurate result unless you're applying the correct material to your part file and all the various other behaviors that that material could undergo. Things that change with rate or with creep, right? Things that cyclically can change. We're able to apply these kinds of complex material behaviors. Cool. Now saying how important that is, it can be very daunting seeing this list of possible materials and saying, how am I going to apply my SOLIDWORKS stuff in here, or my lab testing material data? Fortunately, we also have this capability with materials called material calibration. I have kind of a repeating video here, but watch that data. So we have got black dots here on the right-hand side. That's lab testing. Material data taken from a lab test that we have imported into the program. And then SIMULIAworks is finding for us the best numbers, the best calibration, or the best material properties to be using to best fit this curve, so that we have a calibrated curve, and 2, a smooth one to prevent any convergence issues and to maintain accuracy in our solution. So with this material calibration, we're able to very accurately represent our materials and apply them inside that database very easily. So saying that, let me just show a few of the clicks of what that would look like. It's really not that long. It starts with just using this particular material application that comes with the program. We import our data. This is Excel data, it's CSV data, just a few columns inside of Excel. And here you'll see us do some data manipulation. So you can delete data points, you can kind of shift this curve around as needed. So you don't have to do a lot of the data modification in Excel. You can make those changes live here. Next, we're making a guess on what kind of material property this would follow. We're going to guess elastic plastic first. And that's going to give us some material values here on the left-hand side. Elastic modulus, some other stuff there. We've clicked the button called Execute, and it modifies various material properties until we get a curve that matches our data. It's really 3 or 4 clicks, you saw that right there, but we're able to get this very accurate material data curve that we can now apply to our part files. Good stuff. So that's kind of a summary of our material capabilities.
And what I really like about this, Shani, besides the fact that you mentioned, you can do those whole host of material properties, you can save this directly into a database, and you don't even have to exit your simulation session. Once you've done the calibration, you can you're ready to go. You can essentially plug this curve in and start running your analysis. There isn't because
Just very
within the same
efficient.
application.
I like that. I like that. Just streamlined.
Yep.
Good stuff. Let's get a little bit into meshing because that's a big thing. What do we have in SOLIDWORKS? We have tetrahedral elements. Here I'm going to show you a thermal analysis. Let me pop over to a mesh type. You're going to see hex elements as well. So our brick-shaped elements. Check out that part on the inside. So those are all cube-looking rectangular prisms. So we have the hex method type. We, of course, have shells and beam type elements as well. And then if we take a look on the inside of this model, we can, of course, refine the mesh. So there's some automatic refining capabilities around curves and holes. We can do this boundary type material refinement. Check out how the prisms get thinner near the walls of that fluid. This is a flow simulation setup. That fluid is better captured because we're able to automatically refine the mesh around the walls of the part. Or the fluid in this case.
And you mentioned a very key point. I was about to ask you, this doesn't look like a structural thermal analysis.
Yeah, there's some weird part going through the center of everything, exactly.
Yeah, so what kind of analysis is this? Is this CFD or FEA?
This is CFD, and you're going to notice some interfaces exactly like what Arun's going to show. And the meshing capability isn't different from one to the other. It's the same meshing capability. I just happen to have used it in the CFD tool in this case.
Yeah, that looks awesome. It looks very nice how the mesh gets a lot finer as it goes towards the wall.
Absolutely.
Captures a lot of
capturing that geometry.
Boundary layer effects and so on and so forth. Yeah.
So we had someone ask a question. Omar, I'm going to direct this one at you. So besides just meshing it here in this program, can we import meshes from regular ABAQUS or Simulia or other programs and bring it into this tool?
There is the capability to import using an IMP deck from ABAQUS, a model. So yeah, there is some capability. I mean, the thing to be aware of is not all of the element types that are available in ABAQUS are turned on in the SIMULIAworks tools. So as long as you're using similar elements, you should be able to do that. Although I would argue that, unless it's a huge model, it makes a lot of sense to kind of use the new interface inside of these SIMULIAworks tools to generate your mesh. They're a little bit more intuitive, but there is some capability to import an external mesh.
Thank you, Omar.
Yep.
All right. Oh.
Does Simulia consider itself a direct competitor to ANSYS?
Yeah, I mean, of course, yeah, it does. I would say ABAQUS and ANSYS are probably the two big players in the structural realm. ANSYS has some, they both have their benefits, but I would argue that honestly, having worked at ANSYS, I would say that as a structural solver, ABAQUS is a little bit more robust. And a little bit better, especially when you have ill-conditioned contact problems, reaching a converged solution. But I mean, they're both, top-notch finite element solvers, FEA solvers.
And although there's an overlap in a lot of their capabilities, would you say that that we're building in this SolidWorks integration kind of separates us from an average ANSYS user?
Yeah, I mean, I think that the 3D Experience platform and these SIMULIAworks tools being specifically developed with kind of SolidWorks users in mind, and the way that we import our SolidWorks models, the integration is getting more and more tight, every release of these SIMULIAworks tools. So every few months we see some added benefits. But for sure, I think, and the other thing, Arun, right, is that you're working with one company, right? So Dassault Systems is always going to make sure that the 3D Experience platform and the apps on the platform can consume SolidWorks data, right? I mean, SolidWorks is the flagship CAD brand within Dassault. There are way more users of SolidWorks than there are of CATIA, right? So it's in Dassault's best interest to ensure that the integration is really, really tight and well done. And, you can't say the same for, an ANSYS, right? And that's not taking anything away from ANSYS. It's just, we're on the same development schedule here at Dassault with all of our brands and products. So
I like it. All right. I don't see any more questions coming in, so I'll move to the next big piece here. So we've got explicit dynamics. This is the explicit solver. So this could be dynamic capabilities or crash testing. Let's go and take a look at that. We got some crash testing or drop testing. This is impact testing. Really anything that is happening in a small scale of time. Yeah, any of those then, hold on, this thing was pausing. Okay. Yeah, so the extreme kind of buckling or crumpling scenarios where really a general nonlinear solver, an implicit nonlinear solver wouldn't be able to capture this small range of time, wouldn't be able to capture the material behaviors that happen over those kind of microscales. So with the explicit dynamics tool here, we're able to go much further beyond the deformation scales available in SOLIDWORKS into these very complex realms. Jonathan asked, which solver would I need to perform a crash test involving a fluid-filled shell? With a crash test, we would definitely need the explicit dynamics tool. The level of crumpling and buckling going on there and that interaction between the two parts would require that explicit tool. So
yeah, and I'll show, sorry, Arun, go ahead.
No, go. I like what you're saying.
I'll show an example of this. So if you want to do a fluid-filled cavity, one of the capabilities that's turned on in structural mechanics engineer is what are called SPH elements, smooth particle hydrodynamics, that allow you to mimic a fluid behavior. So if you actually want to see like the movement of the fluid and like, I think I'm going to show a crush test where we can actually see
Plastic
the fluid
bottle.
coming out. Yeah, coming out of the bottle as it's crushed. So there's that capability too. There's also a fluid cavity that you
right. So similar
in SIMULIAworks. So it's just if you just kind of want to kind of mimic a fluid volume and the pressure, you can account for that also. So there's some different ways to approach that.
And when I'm saying explicit, this is the ABAQUS solver, of course, and it's that highest level package that we have in SIMULIAworks. It's called SME. That's the one that comes with this explicit dynamics with that ABAQUS capability. Oh, in case you're more familiar with the ABAQUS side, it would be called the ABAQUS explicit solver. Okay, good. So a huge range of functionality there. And then with the ability to run these kind of complex analyses, I'm sure you're looking at this can thinking, how long did that take to solve? Like, that looks really complex. Fortunately, the can was very simple, and this took maybe 15 minutes. But if it was a very complex solution, I could be worried about that. Fortunately, we have the ability to run things locally on our computers, but also on the cloud, using cloud cores, cloud computers. With the program, you can run it on 4 cores on your local computer, but with a little bit of an extra purchase, you can get access to tokens or credits like I have here to use those cloud-based cores. Now, this is a direct sparse solver, meaning the more cores that we are applying to this solution, the faster it solves with no diminishing returns. So you can get huge time savings running with these cloud cores. Omar, do you have any comments on that?
No, I mean, I think you highlighted it great. So the way it works is if you purchase cloud, so out of the box, you can run on 4 cores, although that's going to be increased to 8, I believe, in later this year or early next year. So you'll be able to run 8 cores locally. If you have cloud computing credits and you have a small model like less than 1 million nodes, it will run on 18 cores, 1 million to 4 million nodes, 36 cores, and then over 4 million nodes, it'll run on 144 cores in a virtual machine. So there's a little bit of time that it takes to set up the virtual machine, but like Shivani pointed out, your return based on the runtime should be very, very linear. So if it took 16 hours on 1 core, it will take 1 hour on 16 cores.
I love it. Great numbers. With that, that's kind of 5 main things I was going to highlight: general contact, complex materials, hex and type meshing, explicit dynamics, and cloud solving. The two other main things that I would consider a core functionality are the ability to push CAD data and, more importantly, design changes from SOLIDWORKS into this tool. And then because of nonlinear solver, we can do sequential loading. Both of these things Arun is going to show in his demonstration. So for that, I'm going to back off of the screen sharing just a little bit, see if there's any questions coming through, maybe ask you guys a few questions, and then if it kind of goes silent, we'll move on to Arun. So I should have stopped sharing. I did. We had a question come in. Is there a different license to run on more than 8 cores locally? It's not really a license. Go ahead.
Yeah.
Go ahead.
No, it's not really a license. You just have to buy cloud computing credits. It's the same interface.
Yes, exactly. Okay. Just to see if there's anybody out there who wants to speak, was there any functionality that I didn't show that you were really hoping to see or needing access to? Okay, so
yeah.
go ahead.
So no, ABAQUS CAE is not going to be phased out. You know, that solver and that product, that desktop interface will still remain, but what you're going to see is more and more functionality from ABAQUS CAE coming into the SIMULIAworks tools on the platform. And the hope is that eventually there would be no reason to purchase ABAQUS CAE, that you would just basically, you know, naturally kind of transition to the platform, but it's not going to be phased out.
And
just like SOLIDWORks.
Just so everyone's aware of the question, I should have read it out. So we're currently using ABAQUS CAE and simulation. Will ABAQUS CAE be phased out? That was a question. And thanks, Omar.
Yep.
I see we have 2 more questions. So we have a question from Jay who wants to know, I assume SIMULIAworks can handle mixed meshes, shell, beams, and solids.
Yep, absolutely. Sorry, I keep answering.
No problem. That's perfect. Yeah, I'll kind of point those buttons out when I'm doing my demonstration. So this is perfect. This is a good segue into my portion. All right, we have another one. Currently, we use ABAQUS CAE for dynamic drop tests, nonlinear explicit analysis. We use complex materials such as molded fibers, foam used in the packaging industry. Should we stick to ABAQUS?
So the hyperfoam material model is one of the ones that's available inside of SIMULIAworks. So I think with foams, you'd be okay. A molded fiber, I would have to know a little bit more how you guys model that. What material model you're using to model that molded fiber, because I don't believe there's a molded fiber material model in the SIMULIAworks material database, but I could take a look. If you want to reach out to Arun and then or Shivani in an email, and we can get that answered. If you could tell me what material model you're using, that would help.
Yeah, and post this presentation, we'll obviously be following up with you guys. So, you know, if you could, we'll make sure that we bring up these questions during a follow-up. But, you know, if you'd like to reach out to us, you have our contacts. Please don't hesitate. We have one more, and then we'll jump into my portion of the presentation. Interested to see how it handles permanent deformation from impact in expanded foam materials or glass fracture.
Yeah, so the brittle, I don't know how you're modeling glass fracture currently, but as long as you have, so here's the thing with fracture, right? Like we show that and it's definitely eye candy. It's very nice to see, but it's very, very mesh dependent. Like you have to have a fine enough mesh to be able to accurately predict the elements that are going to be removed as the fracture is initiated and kind of propagates. So it's certainly something we can do, and we've gotten good correlation. And we do have those brittle damage models available in SIMULIAworks. But, you know, it's a complicated problem, but it's not one that we can't do.
For sure. If you ever want to see this live, like you can give us a model, we can benchmark it and then show it to you. So because you had said you're interested to see how it handles it, we can always show it to you instead of just talking about it.
Great. Now, I'm pretty sure you guys have seen this before, but this is, according to me, the perfect case study to take a look at. The last 2 qualities of SIMULIAworks that I really like that Shivani showcased, which is sequential loading and the fact that it's connected to SolidWorks. So I have this automotive rubber boot, right? You find these in CV joints of automobiles. It's a rubber component that experiences a lot of stress and strains because it's on rotating components mostly. So I thought it would be an interesting case to simulate with SIMULIAworks because I'm able to essentially stack loading conditions. I'm able to essentially compress this component, and also I'm able to apply a torsional load so that that follows the compression, which is pretty easy to set up in terms of workflow, and it gives you some really cool looking results. For starters, you essentially start off with SolidWorks, and let me see there. Okay, you start off with SolidWorks, and how you maintain the connection with the 3D Experience platform is through the 3D Experience connector. So as soon as you open a model in SolidWorks, it shows up on the connector, and all you need to do is save it. So when you hit the save button, there are two copies that are essentially saved, one on your local folder for you to make manipulations, and another on the cloud on the 3D Experience platform. Now, you'll essentially be setting up the simulation on the cloud version of this component. So as soon as the save is complete and the software converts it into a format that the 3D Experience can read, you're able to launch a simulation application right from within SolidWorks. So like Shivani said before, there are two applications. The mechanical scenario application is ABAQUS explicit. You'll just know that it has explicit and ABAQUS standard capabilities. So we have two levels: ABAQUS standard and explicit. Mechanical scenario is explicit. Now you'll notice that I've launched another application, and the models automatically open into this application, and I'll be primarily running a structural analysis. So I select the structural analysis time, and boom, you're in the simulation environment. And just know this model is still connected to the SolidWorks model. So what I'll be showcasing is, I'll be making a change, and I'll be pushing that change through the simulation environment. Now, jumping into the simulation environment, I just want to show you the SolidWorks. That's the connector, and this is the model open in the simulation environment. And immediately you'll see the UI. It might seem a little familiar. You have the spec tree, as we like to call it, which is similar to the feature tree in SolidWorks. And if many of you have used the simulation wizard in SolidWorks, we have something called the assistant panel, which is very similar to the simulation wizard. So essentially, you follow the simulation wizard to set up your analysis, and make sure that all of these stages are assigned. So simulations can sometimes get complex, especially if you're running crash testing for really complex materials. And this is a really handy way of keeping track of the analysis setup. Now,
this taught me the interface, actually, the assistant.
Yep.
That's where I learned where everything was, and then I got crazier after that. But this was my teacher.
Yeah, absolutely. And when it comes to the setup, you have access to all the procedures, all the analysis types right here. So essentially, you see the red circle in the setup indicating that, hey, you haven't specified what kind of analysis you're trying to run. You can essentially interact with the action bar to set up the various analysis types, right? So if I wanted to set up a nonlinear analysis, I can just grab the static step, and I can give this a name and specify the appropriate time step settings, and keep moving forward. And as soon as I complete that, you'll notice there's a green check mark in the setup, so it gives you a lot of feedback. So yeah, I mean, I'd also say I basically use the assistant panel to teach myself the software, and it's helped me be very successful with it. But what I'd really like to show you is the meshing aspect of this entire thing. So as far as the next stage of the setup goes, what I'm able to do is I'm able to assign section properties to each of these components. And this is to answer the question we had earlier, whether mixed meshing is possible. And yes, it is. And you have access to all the section types right here based on what kind of model you have. So here, this is a solid bellow, but the control arm is essentially a shell. So I'll be applying different section properties to each of these. So I'll go in and select the component, and I'm able to assign the material directly here. Once I hit the magnifying glass, I have access to the material database. And I'm able to search my material database, and I'm essentially trying to apply a silicone 60 material here that I already had keyed in, so it shows up right off the bat. But if I actually clear the search, you'll be able to see my entire database. And this was a custom material I created using the material calibration app. So I had the material testing curves that I was able to convert to coefficients. All right, now once the solid section's been assigned, now I'd like to show you the spec tree for a second. Just like SolidWorks, anything you do to the analysis in terms of setup essentially shows up as a history in the SolidWorks and in the spec tree. So where once I set up the solid section property, you can see that it shows up as an item on the tree. So if I want to modify it, I can just double click it. I have access to it. So that way you have multiple levels of feedback to make sure that you're setting the analysis correctly as you set up a lot of these analyses. Now I did mention I'm able to apply shell section properties to the control arm, so I'd like to show you that really quick. Really just grab the section property, select the component and specify the thickness. And you obviously can manipulate whether this is the mid surface, the top surface, or the bottom surface, and you have a lot of flexibility. I won't assign the material here because I'd like to show you the feedback mechanism in the software is pretty great. You'll see there's a yellow exclamation mark next to the shell section indicating that, hey, you've assigned the section, but you probably missed out the property. And that's fine. I'm just demonstrating the workflow, so I'm going to move on. Another really nice aspect of the software that I like, which I'll be highlighting a couple of times, is that it essentially keeps track of your geometry for your boundary condition in your connection applications. Now, one of the main benefits of that is especially when you're trying to define tie contacts or bonded contacts. Now, you can either go in and specify the surfaces that are bonded together, which is typically the bellow surface and the control arm, or you can essentially use this little tie detection tool to essentially find all the touching faces, or you can specify a clearance between the faces to identify them as a bonded contact. And you have a list of all the ties that have been recognized for you to pick and choose from this big tie buffet. I think that's a really cool feature, and especially if you're dealing with like a 20-30 component model and most of them are bonded or welded together, this is a really handy feature to specify either contacting components or clearance between components that are otherwise meant to be tied together.
Before you get too much further, we had a question come in.
Sure.
Will many of these ABAQUS capabilities get imported or incorporated into SOLIDWORKS simulation, like the material calibrator? This is interesting. I see Omar unmuting himself, and I'm going to comment right before he comments. They combine the R&D teams between ABAQUS and SOLIDWORKS simulation, so we're already seeing capabilities come in. If you go check out some of our What's New videos from the past 1 or 2 years, that the physics that's improving inside of SOLIDWORKS simulation is all coming from ABAQUS. But Omar, any more specifics you wanted to say to that?
Yeah, no, I was going to kind of say the same thing. There's been a collaboration between the development efforts on the desktop and obviously the ABAQUS side. So it's all being developed by the Simulia development team. I would probably say that you're not going to see those kind of technology. You're probably not going to see like the material calibration app or the explicit solver ever be turned on the desktop. I mean, the 3D experience platform and kind of the roles and the apps available on the platform are the future for DS. So that's not to say that you won't continue to see development and bug fixes and fixes and streamlining to the desktop SOLIDWORKS simulation tools. But probably the new stuff is going to remain on the platform.
You will be, I don't know if I can add this comment, I'm going to add it anyway. You will see some changes in the nomenclature. Like, we don't call them contacts anymore. We call them interactions in SOLIDWORKS simulation because, again, like Omar said, there's a convergence between the two portfolios, not in terms of technology, but at least in terms of the way they look. And Metori, just to add to your question, we do have a pseudo material calibrator in SOLIDWORKS, so we are able to curve fit some of our hyperelastic material models, but those are the only ones you can, as in you can put in the curve and the software automatically extracts the coefficients, but it's quite limited. It's not as expansive as what we have with the SME. Awesome. Do we have any more questions?
Yep, that was it. Thank you for letting me interrupt you.
Yeah, awesome. Thank you. Yeah. No. Please interrupt as much as like. I have a tendency to ramble on, so these interruptions are great. So where was I? Oh yeah, okay. So we were talking about the tie contacts, and again, I really love pointing out to this tree because to have such a complex analysis software give you feedback on all the complexities you've dialed in is a super nice aspect. And you see the tie contact here again. If you want to get a little more detail into the tie, get in, look at all the faces that have been defined. Make sure you define how the source and target surfaces essentially interact, and so on and so forth. The next aspect is the mesh. I'm going to jump through all of this. Actually, you know what? I'll show you one more thing, which is the restraints application, again, to emphasize the fact that all of this is applied to the face of the component. So any change you make to the component, it's going to update the component here, and it's going to update all the boundary conditions applied, and that's going to be mapped onto the mesh. So that's a really big advantage of being able to apply these boundary conditions directly onto the geometry. So, you can imagine this is probably going to be clamped down. So I'm going to select that face. Again, feedback, you have a big exclamation mark here. It just means that it's missing the mesh. Essentially, that will be corrected as soon as I apply the mesh. Okay, the mesher. As Shivani pointed out earlier, we have various meshing types that helps you dial in different degrees of complexity in terms of how you capture your model. And really, anytime you have this kind of swept geometry or extruded geometry, the sweep mesher is a no-brainer. It applies really high-quality hex elements to solid models. So, for instance, this is a revolve component. As soon as I select the component, the sweep mesher has identified the revolution direction and the start and the end face. I'm able to specify the element quality, and I'm able to dial in the mesh size. I can get the software to either guess the mesh size, or I can just dial it in. Because I've run this model a couple of times, I know what the ideal size is. And I'm also able to put in the number of layers of hex that's going to be essentially employed as this thing is being swept through. So as soon as I hit the mesh button, there it is. You can see that the model, again, has intelligently recognized the start and the end face, and it's essentially discretized that face along the sweep direction. And, you can do this for various kind of swept models. It doesn't have to be perfectly, extruded or perfectly revolved. As long as the start and end faces are similar, you should be able to get away with using the hex mesher. There is one more aspect I'll show you, which is the check elements. Anytime you get into these crash type analyses or these large deformation analyses, you want to make sure that you don't have any element collapse and so on and so forth. So this quality analysis tool is really handy. As soon as you grab it, you get to see all the green elements that are good, all the yellow elements that are bad, and all the red elements that are really bad. I don't have any really bad elements here, but then I noticed that there are some yellow elements indicating that these hexes might be, out of aspect ratio. So I can fix that again, going back to, well, I'm pretty sure if you guys were guessing, you guessed it, the spectry. I'll double click the sweep mesh on the spectry, and I'll just increase the number of layers from 25 to 50, increasing the number of, the discretization in the swept direction. You have a nice little mesh. And then I can really go back to the check and justify that, hey, I've made a change, and, it's positively affected my model in terms of the aspect ratio of the mesh. I'm going to save this, and I'm pretty sure you guys get it by now. I mean, after this, there's just a couple of steps where I apply the boundary condition to this control arm to pull the bellow down and essentially deflect it. So I'm going to jump into another tab that Shivani and I have been constantly referring to during this presentation to show you some results, right? So while I access these results, do we have any questions?
Where are they stored? It looks like you're downloading them. Why don't you talk about that?
Oh, perfect. Yeah. So there are two modes of storage. Of course, the model is stored in the cloud. But as far as the results go, you have two options. If you're dealing with really large results and you're iterating through multiple designs, you have the option to store the results locally on your hard disk. But by default, the results are stored on the cloud. So it's a common space that's shared by everybody in by all the designated users in your organization, and essentially you're able to use that common space to dictate who gets to view the results and who don't.
Omar, do you mind commenting on like the cloud storage itself, on what kind of servers we're using or that type of topic?
Yeah, so we're using a mix of different servers. So the data is stored in the cloud. There's some information online about the cloud security that DS is using. Obviously, it's a very secure cloud. Our architecture is very secure. It's going to be stored, if you're in the US, on the West Coast, I think there's a server in LA or San Francisco. There's one in California. If you're on the East Coast, there's one back in Boston. So yeah, I mean, that's kind of it, right? So the data is stored on the cloud. You can download it locally and have it available locally, but it meets all the requirements related to like cloud security. And we can maybe share the link for you guys to download the white paper about cloud security if you're interested. And I apologize. I think I got cut off. I came back on, so I don't know if I missed anything, but.
Oh, no.
No, you're good.
Yep.
Okay.
Awesome. Let me just show you guys the results really quick. And this is the sequential loading that I keep talking about, or that we keep talking about, where I have access to the two steps here. That's the end of the first step. And when I switch to rotate, that's the beginning of the next step, just starting from the previous step. And I'm able to apply the torsional or the or I'm able to apply the loading condition, the angular loading condition after the first step. And as far as post-processing goes, you have all the usual options. You can turn on symmetry plots, and you can turn on isoclipping and section plots, and so on and so forth. But there's one thing that I'd like to highlight, which is in the analysis setup, which is actually, there are a couple of things I'd like to highlight. The first thing I'd like to highlight is the way these loading conditions, multi-step loading conditions, are managed. The first thing is you'll notice that I'm able to switch between the two steps that I've created. So as soon as I grab the down step, you'll notice this applied translation goes on that essentially pushes this down. And once I switch to the rotate, this applied rotation goes on that then rotates the model. But there's another handy tool that you can use to manage this, which is the feature manager. Once I go into the feature manager, you can see that all my steps are laid out, and I'm able to turn on and turn off each of these boundary conditions in each step. So if I have a 3 or a 4-step loading, and my feature tree or my spec tree is just packed with the loading conditions, you'll be able to use the feature manager to kind of dial in what comes on and what turns off during the loading process. With that, let me jump back into SolidWorks and let me show you guys the change I'm going to make to the model. And now I've noticed that the bellow was essentially buckling in this section. So I'm going to try and change the model so that this section becomes thin. It becomes shorter than it is. And for that, I've got to remember to obviously reserve the component, because again, since you're operating in a common environment, you want to make sure that you have access to it and nobody's making changes while you're working on it. And the next thing I'm going to do is I'm going to in context edit the sketch that drives the shape of the component. I'm going to make a couple of changes, and I might jump back into the presentation for reference, but let's see. Again, my ultimate goal is to try and make that section as short as I can make it. Yep, I think those properties are correct. Let me jump back to the presentation, make sure. 2.75, 150, and 2. Yep. Just make that 2.75, 150, and 2. Perfect. And now that I've made the change in SolidWorks, now I'm going to exit. You can see that the model's changed. Now I'm going to go into my panel, and it's going to indicate that, hey, there's a difference between the SolidWorks version and the version in the simulation environment. So I'm going to quickly upload this by just hitting the save button.
So this is looking like a PDM thing, obviously, right? A data management type tool.
Yep, absolutely.
Something I wanted to mention is this is with the 3D Experience platform. As part of getting access to the 3D Experience platform, you're getting access to this kind of PLM interface.
Yep. Again, the philosophy behind the 3D Experience platform is to make sure all of you are able to work in a collaborative environment on design and analysis, and you want to make sure you aren't fighting on your model. So there's definitely an undertone of PDM technology essentially driving to make sure you're successful in that. Yeah, that's a great point, Shivani. And can you explain to the audience what I'm about to do right now?
Well, you should have watched my searching video on our 3D Experience tutorials page.
Yep.
But what Arun is doing is using some keywords like the sim : filters all of his files for simulation files specifically. And that bar he's searched in is generally like I call it kind of like a Google search bar. It's just searching all the data available on our shared cloud database. And yeah, he was able to find the file pretty quickly by doing like a filtered search,
yep.
Just like that.
And you can see I have about 251 simulation files already. I just fished this out using a couple of keywords, as Shivani mentioned. And you'll notice the mesh still remains the same as my older model, but the model has essentially changed. Again, I can quickly enforce this change by hitting the update button, and the software should essentially update the mesh to match the model. And you can imagine working this in a 25-30 component assembly, right? It just makes your analysis process a lot easy. Again, that was to show you a little bit of the SolidWorks connectivity. I'll just show you the final design of the bellow, so that you guys can see how different
what it looks like.
What it looks like.
Well, too late now. But can you answer, are there rigid parts available? I was going to have you show the button, but
yeah. So yep, absolutely. There are rigid parts available. And the nice thing about the rigid parts is you're able to specify a control point So you're able to get key pieces of data like forces, and you're able to use that control point to essentially manipulate and move the model. Matter of fact, in this example, this control arm was meshed as a rigid part. So that's why in the results, you don't see any stresses. You basically see just a white control arm, which is the application default.
Yeah, makes sense.
Do you have another question?
The control points is a very interesting thing. That's something that SOLIDWORKS simulation doesn't have, right? We can make a rigid part, but
I guess we'll have to
we don't have that control over it that a control point could have.
Right.
Or we're driving it based on the center of mass or based on a point on a face. Yeah.
Right, absolutely, yeah.
We had another question come in the chat, but it's quite long. Perhaps I'll copy this into a slide. How about that?
Perfect, yeah. We can save this for the end. And guys, I have results for both the components, and I'd just like to show you one more piece of interface eye candy before I hand it off to Omar, which is if you have multiple tabs open, if you've iterated through multiple designs, I can grab this compare results button, and I can basically grab any simulation result from my current session. For instance, I have the Bellow Design 2 von Mises results loaded in. I'm just going to drag in the Bellow Design 1 von Mises stress. I'm going to say OK, and I have access to both of these results essentially synchronized, and I'm immediately able to see, what my how my design change affected the stress result. I mean, I probably didn't get too far with this section. This is probably still going to be a problem, considering that I have concentrated stresses instead of something that's nice and spread out. But then I think I did attempt to correct one area. So I personally consider that as a win. Yeah.
Very cool. I think I'm going to go ahead and pop up this question because it leads into what Omar is going to do very well, because it's about an industry example. So can you guys see that question? So because that would have been hard to read, we're using this slide. But can pre-processing to generate nodal loadings or surface pressures be brought in either by a spreadsheet or some kind of external data import for multiple load cases? Let's say like a CFD, like importing results from CFD analysis into the FEA analysis.
Yeah, so that's a great question. I'm unmuted. Yeah. Okay, perfect. So there is a way to import load data based on spatial data. I actually haven't tried it yet, but it is available in the loading. So I believe that it's available. I think you'd be able to. And I don't think that the nodes even have to line up. I think it does some 3D mapping for you to import that data. But that is one I would need to double check on. So I'm almost 100% sure that it's available in SIMULIAworks. But like I said, I haven't tried it. But I thought I played with the pressure loading or force loading before, and one of the options was to bring it in via an input or spatial data.
And you're really referencing like any general program being able to import that kind of FEA in. I believe the Fluid Dynamics app can push results to the FEA app, right, on SIMULIAworks?
There is a method to do that, yeah. So if you're there's definitely an approach to do that if you're using the Fluid Dynamics Engineer on the platform and then pushing it to one of the structural tools on the platform. And
having said that, it just occurred to me that if you're using SOLIDWORKS flow simulation and SOLIDWORKS simulation, you can do that push. So agreed that we can't do it with some generic program, but if you have SOLIDWORKS flow simulation, you can push the pressure mappings into SOLIDWORKS simulation.
I guess I missed that last sentence. But if you have SOLIDWORKS flow simulation and SOLIDWORKS simulation, so the flow solver and the desktop, or the structural solver on the desktop, you can do this. You could do a wind load case and then take those pressure loads and import them into SOLIDWORKS simulation. And that's something, Arun, Shivani, or myself can show whoever asked this question.
But I'm glad that you mentioned that first part, because the ability to generically import something from any program is interesting to hear for sure.
Yeah.
Because not everyone's going to be using flow. When you had a question come up for yourself.
Yeah, I mean, I'm going to defer this to Omar. So in this example, is there an optimization function? Adjust dimensions within a certain minimum, maximum to minimize stress?
Yep. Okay, so that's a really great question. So right now, the answer is no. In the release that's coming, the next release that's coming, you'll be able to do parametric optimization. just like you described. So you'd be able to do an optimization where you're playing with the SOLIDWORks parameters, driving the SOLIDWORks design, and then giving it an optimization goal like minimizing weight while keeping natural frequency below whatever, or maximum stress below whatever.
Cool. We had another question come in. This one's definitely for Omar. There's a .inp files available for manipulation. Can we submit
Yes.
those?
So you can write out the .inp file, and then if you have ABAQUS, you can certainly manipulate it. It's just a text file. So if you understand kind of the underlying ABAQUS programming language, you can do that. Can you submit it back to the SIMULIAworks solvers? It depends on what you add. If you add features that aren't available in SIMULIAworks, no, you're not going to be able to. But if you have ABAQUS CAE, you can certainly write out the input deck and then manipulate it as you see fit and submit it to ABAQUS CAE, if that makes sense.
So you're able to write out IMP files from SIMULIAworks, and you're able to import some data from using IMP files like materials and.
Yeah, I mean, it just depends on what the data is, right? That data, it has to be features and functionality that's available in the SIMULIAworks tool. So I would argue that, again, your best approach is to probably take a look at SIMULIAworks and see if there are certain features or inputs that aren't available in these Simulia tools, and then go from there. I mean, we can certainly help with that.
Okay. We'll watch out if Ryan puts up a clarification. But I don't see any hands raised. You guys, if there's any questions you'd like to say out loud, feel free to. But I don't see any more questions coming in. So Omar, if you wanted to show some of your examples, that would be awesome.
Yeah, sure. So let me know if you guys see my screen.
Looks good.
Yep.
All right, so I've been working on this model the last couple of days, so I thought it would be an interesting one to show you guys this. And, being that I'm based in Southern California, as is Arun, the bio industry and biomedical is really popular. So in the last release of the SIMULIAworks tools, we included the material model for nitinol. So this is an example of a nitinol stin. It goes through the crimping phase, the expansion phase, and then a pulse. And again, the nitinol material models are all available. ABAQUS is heavily used in the bio industry, biomedical. So this is a really nice feature for us to have now. And just like Arun showed, so this is using the general contact, just like Arun showed. I believe there are a couple no, they're not. They're actually not bonded together. So
actually, Omar, I didn't. That's one of the things that I wanted to highlight, but it skipped. Can you remind us what the general contact feature is again?
Sure. So I think Shivani highlighted it earlier. Basically, the way ABAQUS approaches contact or interactions between bodies, and the way is very different than the way SOLIDWORKS simulation does, or the way that ANSYS Workbench does. To be frank. The assumption inside of SIMULIAworks is that any faces, whether they're touching or not touching, can come into or out of contact. It's a no penetration contact. Now, I think, Arun, you showed a tying feature. So if you want all the faces that are touching to be tied together or bonded, like in SOLIDWORKS simulation, or the way like an ANSYS would approach it, you have the ability to do that. But the default general contact used in these tools is, it's a no penetration contact. And faces don't have to be touching. They can be out of contact. I'll show a couple examples. Or the example that Shivani showed of that like honeycomb structured twisting is a perfect example of faces that weren't in contact initially that end up in contact. And you have the full range of you have the ability to specify the friction coefficient. You can resolve interference if that's something that's important to you. So you've got access to all those capabilities, but really with just a push of a button. There's not much you need to do to turn on general contact. So I'm going to walk you guys through a couple examples. So we've been, and I'm going to focus on consumer packaging and high tech. Those are just two industries that we've had a lot of interest in with these tools. So I am going to, and the reason why I'm showing this is we actually have had a couple consumer packaging and bottling companies that have come to us and asked, how we would approach, some of their use cases. So this first example I'm going to show is we're taking this consumer product. You can see the design inside of SOLIDWORKS, and we are going to use the same approach that Arun used to import it into the platform. And then you can see we can run kind of like a nonlinear buckling test. We can obviously investigate all of the results, whether it's displacement or von Mises stress. Here is a drop test of that same consumer product. This is using that SPH approach that I talked about earlier. So those dots in the center of the bottle are actually modeled as, it's modeled as a solid, and then you kind of particleize it using smooth particle hydrodynamics, the SPH elements. And we can get a feel for exactly how those, how they move. And you can also see some of the permanent deformation here on the bottom as a result of that drop. Let's take a look at, so I think the value comes across, right? You can quickly validate your designs. You can test alternatives using the approach that Arun just said.
When I first saw, oh, sorry for interrupting. When I first saw those SPH elements, my background's in aerospace, and this was recently after that. Remember that plane that ran through the flock of birds and the engine broke down? I've seen these SPH elements used to represent a bird, actually, or it doesn't have to be fluid, right? It could be something like meat, and you want to see it break apart. Yeah.
Yeah, anything that you've kind of got material properties for the way that it's going to break apart. So I'll show you guys an example where we actually do that. We actually do a bird strike. It's one of the videos that I'll show at the end. But yeah, that's another common place where SPH is used. I've seen it used to like model sand too. When I worked at ANSYS, we did a lot of work with golf club companies. So they would often model their like sand traps if they wanted to see how a ball was going to emerge, and the sand would be modeled as SPH.
We had an SPH question come in. Sorry to keep interrupting, but is it similar to the lattice-Boltzmann method?
It's similar, although it's not the same. It's a different approach. It's not, the lattice-Boltzmann method is a little bit, lattice-Boltzmann is typically used in fluid dynamics. So SPH are typically used in structural analysis where you're trying to mimic a fluid behavior.
Cool. And that drop simulation, the plastic bottle crushing, how long did that take you to calculate? Or the one where it was dropped and then the SPH elements were scattering?
Yeah, this guy, so this solved within 2 hours. Now I'm using the cloud, although it's a small model, right? So I'm using 18 cores on the cloud. It solved in 2 hours. So if you were running it on 8 cores, it might take a little bit more than 4 hours to solve.
It's not bad, especially considering all the interaction between the particles themselves.
Yeah, absolutely. And that's an example where, someone talked about mixtures of, so in this case, the bottle is modeled as shells. The top and bottom are modeled as rigid elements. And then you have the SPH, which is modeled as a solid TET. But again, then it's turned into those particles. So another not too common thought of simulation that you can actually achieve is blow molding. So again, this was an example or a model that we ran for that bottling company who wanted to see how we would approach this. So we can very quickly and easily model blow molding or thermoforming types of events to get a feel for what the final shape is going to be, how much pressure is going to be required.
And this is another one of those that takes sequential loading, right?
It is, yep, absolutely, Room. So yeah.
And is there a thermal component to this analysis?
This one doesn't. I don't think this one has a thermal component, no. But you can see this one is using the cavity pressure. So there's, an internal cavity pressure, which is another way that you can kind of approximate some of the fluid behavior, in these roles. So let's see. Here's another really interesting one. Doing drop testing of a packaged group of products. So in this case, we can quickly put together all of those bottles, put them in a box, and then see what happens if we drop that box. See the interaction between the components. I mean, this is just you just wouldn't be able to do this with SOLIDWORKS simulation, right? And I'm sure that everyone has ordered something from Amazon that has come damaged. So this is a very relevant type of analysis. I know that since everybody's just ordering from Amazon now, since we can't leave our houses, whether it's, shampoo
It's
or
almost like you planned
anything
this
else.
example from Coke bottles to
Yeah,
packages.
so I don't want to talk a lot about it, but we did talk a lot about the collaborative aspects of the platform too. And I just want to hit on it like for a second here or 5 seconds. One of the really nice things about the 3D Experience platform is the ability that it gives you to collaborate with people that work in different organizations and different geographical locations. And, I'll be the first to admit, I think the SOLIDWORKS brand was a little bit resistant to the 3D Experience for a little bit too long. And what we've really seen in this year with with COVID-19 and everybody working from home and is that it really, really provides a business benefit. It allows you to do a lot of your work in the 3D Experience platform and collaborate, again, with different functions, whether it's marketing or sales or, R&D or technical support. It's been really eye-opening in the last handful of months to see what we can do with it.
It reminds me of interfaces that are like social media, like that we're commonly using when maybe like Facebook or something like that. It feels like that. That's why it's easy to kind of comment and talk to your coworkers.
Yeah, absolutely. So a couple other examples. So ISTA is, I think it's short for the Industrial Safe Transit Association, or it basically has to do with, it's a set of requirements like mil specs in the military realm that dictate the types of tests you should subject your consumer packages to ensure that they're going to withstand shipping. And we're able to basically do all of those tests. So whether, it's drop testing, transportation vibration, so, if it's, a random vibration curve or a shock response spectrum, stacking load. We're really able to hit a lot of those ISTA test categories. And that really minimizes, the amount of time and money that you have to spend doing virtual testing or doing real testing, right? So I don't know if anybody's had the opportunity to work with like a shaker table, but it takes a lot to set up and instrument a shaker table and then, extract the results. So, if you're doing harmonic testing or, random vibration testing, a lot of times we can really eliminate a lot of the need for some of those physical tests. A really nice example of a corner drop that this is a company that we worked for that had some really specific material properties for their cardboard and exactly what was going to be inside. And we were able to really hit the nail on the head with respect to what the deformed shape was going to look like when it was dropped on the corner. A nice example of compression testing. Again, if these things are going to be stacked on top of one another to get a feel for whether or not the products inside are going to be damaged. Let's see. Yeah, so this is really cool. So, being able to see side by side these types of tests. So when you're going, you can see that the vehicle is going over kind of like a bumpy road. So down here, you can see there are some bumps. So we mimic that inside of with our inputs inside of the SIMULIAworks tools, and we can really get a good feel for what's going to happen. And this would give you an idea of whether or not you need to add more, plastic or wrapping around these in order to ensure that when it does fall over, that everything doesn't break apart. Or maybe potentially add more stabilization to ensure that when it does go over those roads, they're not going to fall over. Another example of like a G-force test. So you can see we're shrink wrapping that and then running it into a wall. Let's see. Yeah, so I think this is a shock response. Or just kind of some G loading.
The way your increments are spaced out, it seems like it's an explicit analysis.
Yeah, maybe you're right. Oh, you're right. Yeah, based on the increment size, you're right. It is an explicit analysis room. Good call. So you're just applying some G loading in the vertical direction. And you can see this box in the middle could potentially shake loose, right? So this would be an example where you would probably need to add more wrapping, right? And that's something that we can do, analyze that the palette film wrapping really easily also. So let's see. So also being able to do thermal analysis. So this is something you can do with SOLIDWORKS Flow Simulation. You can also do it utilizing the Fluid Dynamics role on the platform. It's a product called Fluid Dynamics Engineer. The benefit of doing it on the platform is that one of the real huge benefits is the ability to use multiple cores and get that linear rate of return when you're running analysis. SOLIDWORKS Flow Simulation, you kind of get diminishing returns after about 6 or 8 cores. You don't with the platform tools. So we can get a feel for exactly how fluid moves through this.
And Omar, if I can interject, I guess one of the big, I'm a big flow simulation fan. One of the big things I like about flow is that the automatic fluid volume recognition. How does Fluid Dynamics Engineer handle that?
Yeah, so it's got some similar functionality to allow you to recognize an internal fluid domain. If it's an external fluid domain, you need to kind of set up the bounds yourself, but it's similar to SOLIDWORKS Flow Simulation. What is different is, SOLIDWORKS Flow Simulation uses that partial cell technology to handle the interface between solid and fluid, which is really, really cutting edge, but it does come with some limitations, right? So it also uses a Cartesian grid. You're not limited to a Cartesian grid here for your mesh. The mesh is actually on your geometry. So that there are benefits to both, but then obviously you can take like we discussed earlier. So this is an example of taking those thermal results and taking a look at what taking those flow results, or the thermal results from the flow tool, and seeing what the von Mises stress and deformation would look like. So let's see, let's take a look. Another really compelling example, and I kind of funny timing, Arun, I know we have a call after this to discuss something just like this, but this was actually from last week at the ModSim event that SIMULIAworks threw. So you can see the ability to run a drop test and add all that fancy background to keep your bosses happy so that it looks like it's actually happening on the shop floor.
And this also looks like it was animated in the 3D Experience platform.
It was, yep. So it's using the 3D Excite, that creative experience inside of 3D Excite. We didn't talk, so another thing that I think it's important to highlight is, in addition, Simulia has a ton of different products that allow you to solve for lots of things. So this is showing an electromagnetic solution. So, looking at the electromagnetic energy that's being generated as a result of this phone being used, right? So a handful of years ago, Simulia acquired a product called CST, which allows you to do electromagnetic analysis. It's something that I wouldn't be surprised if the next SIMULIAworks products are going to include an electromagnetic solution. It only makes sense to turn on these capabilities for, the SOLIDWORKS users. But there are also things for system analysis, really, really complicated durability and kind of fracture and failure analysis. There's really great acoustics modeling. There are some really, really powerful flow simulation tools. One that specifically uses lattice Boltzmann that I actually think we're going to be seeing in Fluid Dynamics Engineer or another product really, really soon. So with respect to, high tech, if you're interested, you can definitely do electromagnetic simulation. This is just some more, this is more for RF and defense, the defense industry, and specifically RF analysis. So high frequency electromagnetic simulation is something that you can do along with electromagnetic interference. Obviously, checking the effect that it has on a human is something. So where the phone is positioned with respect to the human head, and ensuring that you're not going to be causing any damage, to humans as these things are being used, is something you can do with CST. And then obviously all the structural analyses, right? So whether it's drop testing or thermal analysis or ensuring that your device isn't, the stresses aren't going to be too high, or it's not going to break when it falls. All those types of, durability, reliability, ensuring that your product, when it does come to market, is going to meet, the market requirements. And yeah, so here's a couple more examples. This is a structural performance engineer doing a 3-point bend test on that phone example. So nothing too life-shattering, but we can get a feel for exactly what the displacement is going to be on that phone.
Although you're not showing it, all the internal components are properly modeled in there, right?
They are, yep, yeah. So there was a slide a bit earlier that showed the internal components that are inside this thing. Yeah, so all of these guys are included. So when you do that 3-point bend test, if you've got if you actually have like the interface material between these components and the board, and you know the damage properties of those interface materials, you could actually do that 3-point bend test and see if components were going to pop off. If the interface material was going to fail. So.
Would you be able to go back and show the packaging on the getting shake tested, that explicit dynamic test that you did?
Sure.
We had a person come in late, but this is basically the example they asked about.
Let me just.
But while he pops that up, to that question that's in the Q&A, this would be the highest level FEA product we have on SIMULIAworks platform, or SIMULIAworks. It's called SME, Structural Mechanics Engineer. And Omar's showing this video here on the right. So this is a packaged component undergoing a shaker table test or an earthquake test. And as you'll watch the results, that box pops up in the middle. So this is factoring in sliding friction. It's not all bonded together like we need in SOLIDWORKS simulation.
So let me I know we're running out of time, and I don't want to take people's additional or more time than what we signed up for. So here are some examples of just models that we've been able to solve, in the last few months using these tools. So Shivani, you mentioned that bird strike. There's a bird strike analysis. A lot of forming, metal forming. The blade damage is another cool one. So provided you have the damage model or the appropriate material properties to model the damage of the blade, the bottle crush filled with SPH elements is another cool one.
We had a second question come in, since we're nearly, people will probably have to start getting out of here. You'll see that there at the bottom of the Q&A section. It's about thermodynamic simulation of lithium-ion batteries. Let's see. Can we do that kind of complex thermal analysis?
So I'll be honest, I'm not familiar with the type of thermal analysis that would be required for a lithium-ion battery, but we can do thermal analysis. So I don't know where the loading, the thermal load is coming from with a lithium-ion battery, but I'm going to assume that we can. Tesla is a customer of ours, so.
Joule heating is one of the features in Fluid Dynamics Engineer, right? So you can put in current as a boundary condition if necessary.
Yeah, you can do I2R heating, Joule heating.
Which is technically also possible in Flow. This sounds like it'd be an interesting one. We might just have to talk to Chris one-on-one with. Unless, I don't see any other questions coming in. So Chris, if you wanted to unmute yourself, you could. If you wanted to say something. When do you guys have to go for your next call?
At least, we have to wrap this up in about 10 minutes. It'll be good.
How about you guys? We've had this question kind of repeat a few times, and Arun answered it in the Q&A, but people seem to be concerned that SOLIDWORKS simulation isn't going to continue updating. Do you mind just saying it one more time, Omar, that SOLIDWORKS Sim isn't going anywhere?
Sure. Are we recording?
Yeah.
Just kidding. Look, to the best of my knowledge, it's not. It's a flagship product. It generates, it generates a lot of revenue. There are a ton of users using the desktop simulation tools. So, it would be extremely short-sighted, at least in my opinion, for Dassault to eliminate that tool. And we haven't been told that. We've been told that product will continue to be developed. There will be bug fixes. When it makes sense, there'll be a transfer of capabilities from Simulia into the desktop product. So I don't I don't see it going away.
Can you guys talk about how the recording is going to go out to everybody?
Yeah, so we'll have yeah. So you'll have access to this presentation on our YouTube channel. So as soon as this is done, we'll package it up and essentially upload a YouTube link. And again, you'll have personal follow-ups from us, and we'll make sure to send out those links during the follow-up. So yeah, this entire content is recorded for you guys to stream, and you'll have access to our through either your account managers or through my direct contact. You'll have access to all of us if you have any follow-up questions. Based on the content you've seen in this webinar. So,
thank you. I know you guys have to go soon, but we had one more question come in about preliminary, the modeling tools. I think that sounds like the feature manager. It's saying to make sure things are working step by step until you run the complete model. Does that sound like the feature manager to you guys, which has the yellow bands and the red bands and then the warnings?
Yep.
Yeah. Arun, do you happen to still have that? Do you still have that third model up, or did you close that?
All right, here it is.
And if you could hit that feature manager, because this is the one that's missing a material, so it'd be awesome to see this. So this is kind of what you're seeing. So everything that you're setting up is popping up here in this feature manager tree. But if you miss something, you're going to get a warning. It's going to highlight red like this, and you hover over it, and it tells you what's wrong.
Yep.
You go fix it. Right-click edit. If that's not what you were asking, please write another question here in the Q&A.
Yep. And we have plenty of videos walking you through soup to nuts how to set up a part and how to set up an assembly. We have a dedicated channel on our website for 3D experience tutorials, so you can definitely take a look at that. And just to add to Shivani's point, there are 3 modes of feedback. One, we have the spec tree that again gives you all of these warnings with these yellow warning marks. Another one, the feature manager, is a great tool. I'm pretty sure all of us on the call use this pretty heavily. And the third one is the assistant panel. Anytime you feel like you're lost in the analysis, you don't really know if there is a certain step that's been completed, definitely watch out for the green check marks.
Okay. Thank you guys so much for coming. I would have loved to talk to more of you, but we talked a lot, it sounds like, me, Arun, and Omar. We're going to follow up with each of you, and if you have any questions at all, please feel free to have that conversation with us later or email us directly. We're happy to answer any questions you have. Even if it's just SOLIDWORKS simulation side, we're here to help.